Welcome learners to today's lesson of exponents and scientific notation. So let's start off with a did you know? So did you know that in the same way that exponential rules make it easy to perform calculations, exponents also make it easy to write very big numbers and very small numbers. Some numbers may even be raised to negative exponents. So for example, we have that number there, which is very small. And we know that it's very small because we have a 0 in the ones position and no other numbers in the other placeholders. So it can be written as 1 multiplied by 10 to the exponent negative 16. So let us see how that is possible. In today's lesson, by the end of this lesson, you will be able to know and use the general exponent laws, perform calculations using numbers in their exponential form, and solve for problems in the context of exponents. So let's look at the focus of today's lesson. We are going to be looking at law number 5, which focuses on powers with integer exponents. Then we are also going to be looking at powers raised to an exponent 0. Then we are going to look at calculations with numbers in their exponential form involving all the exponent laws. And lastly, we are going to be focusing on scientific notation. Let's start with some pre-knowledge. So you should be able to apply exponent laws for multiplication and division, apply exponent laws for powers, products, and quotients, perform complex calculations involving numbers in exponential form. Let's look at the following questions and see if we can remember these exponent laws. So for number 1, we have 3 multiplied by 3 squared multiplied by 3 raised to the exponent 7. So you remember what law 1 said, that if we have the same base with powers that are being multiplied, then we are going to add the exponents. So I am going to add the 1 for the first power there, plus 2 plus 7. And that gives us a final answer of 3 raised to the exponent 10. Let's move on to the next one. So we have 6 to the exponent 12 divided by 6 to the exponent 4. Another reminder again that if we are dividing powers of the same base, then we are going to subtract the exponents. So this means we are going to have 6 to the exponent 12 minus 4. And that leaves us with a final answer of 6 to the exponent 8. Our next example, we have 8 cubed, and that power is raised to the exponent 5. So if we have a power that is raised to an exponent, then it means that the two exponents will multiply with each other. So that means we are going to multiply 3 with 5. And our answer here is going to be 8 raised to the exponent 15. And lastly, we have 12 cubed. Now, to make this calculation easier for us, we are just going to write that 12 in exponential form, and that is 2 squared multiplied by 3. Now this product is still raised to the exponent 3. Do you remember what happens when a product is raised to an exponent? Yes, we are going to say that that is 2, and we are going to multiply the 2 and the 3, which is going to give us a 6. So that is 2 raised to the exponent 6 multiplied by 3, and again we are going to multiply those two exponents, and that is going to give us 3 cubed as our final answer. Let's look at the last one. We have here 4 raised to the exponent 5 multiplied by 4 squared, all divided by 4 raised to the exponent 4. So again, we have powers that have the same base. We are going to say that is 4. And we are going to add the exponents, that is 5 plus 2. We are going to divide this by 4 raised to the exponent 4. So what is 5 plus 2? That is 7 and we still have the 4 there. Again, we are dividing powers that are the same base. So we are just going to subtract those two exponents, and that is going to give us 7 minus 4, which is a 3. Okay, I hope you remembered how to do those questions. Let's look at the words that we are going to be focusing on, a new word in this lesson, and that is scientific notation. So scientific notation is a way of writing numbers that are too big or too small. For example, we have that big number there. Do you know what that number is? It is 150 million, and it can be written as 1,5 multiplied by 10 raised to the exponent 8. So we are going to learn in our lesson today how that becomes. Let's look at our concept map again, and we are going to be focusing on law number 5. So we are going to start there with powers with integer exponents. So law number 5, we have there a raised to the exponent negative m. So we have a negative exponent. What happens in this case? Can you see how that will change to 1 divided by a raised to the exponent m? So our power now becomes a denominator, and our exponent becomes positive. Let's look at an example with numbers. So we have there 7 raised to the exponent negative 2. So according to our law, what is going to happen? Yes, you are correct. That is going to be 1 divided by 7 squared. And what is 7 squared? We know that is 49. So that is another way that you can write it there. Our answer is going to be 1 divided by 49. We have 2 raised to the exponent negative 3. So what is that going to become? Yes, you have it. Our exponent is going to become positive. Our power moves to the denominator, and we have 1 divided by 2 exponent 3. We know that 2 cubed is 8. So our final answer is 1 divided by 8. Now, what happens if the negative exponent is already in the denominator position? So now, firstly, it is going to go to the numerator position, and it is going to multiply with whatever number will be in the numerator. So let's look at an example there. We can see that 1 divided by a to the exponent negative m becomes 1 multiplied by a to the exponent m, which will give us a to the exponent m. An example of this, we have 1 divided by 7 to the exponent negative 2. We are going to take the one that is already there in the numerator, multiply it with this power, and the exponent now is no longer negative but becomes positive. So that is 1 multiplied by 7 squared. And that is just 1 multiplied by 49, and our answer is 49. The same can be said with this example, but now we have a 4 as a numerator. So what is going to happen with our negative exponent? So I'm going to write the 4 there, and I'm going to multiply it with the power. The power is no longer a denominator, it becomes a numerator, and our exponent becomes positive. So that is equals to 4 multiplied by 2 cubed, which gives us 4 multiplied by 8, and our final answer is 32. Let's quickly go to an ad break, and then we'll see you just now.